Hello. Today we will focus pretty much on wires, but we still will extract it from existing geometry. We will perform a lot of cool things in terms of control and adding character to these wires, and we will learn a lot of useful techniques that can be applied on many projects. Before we go on with wires, I would like to fix one issue. It's not obvious, but we have unpredictable normals. Here, as you remember, I've created a normals and wanted to carry it over my graph. I've defeated pick node. I disabled recompute point normals on that. But here, when I apply fuse, as you can see here, for example, I have like predictable normals that I've set. After fuse applied, you see my normals is pretty much all screwed up. And it's pure luck, the fact that we have predictable result. So we should disable recompute affected normals on fuse. Better way of carrying over this vector would be to put normals on some different attribute, but because we already did that on normal attribute, we just can fix this fuse node. And now I can change the way polyextrude works, and I can use just positive distance, which is more predictable than previous one. And now we will have much more clean result. At least it's predictable. Right now I don't need any of this edge damage for the moment, so I will disable it to just make it calculate faster. So now we have our potential issues fixed, and we, for example, can, without any worry, increase the divisions in circle, and we still will have proper geometry. This is pretty much for later stages to correct this amount of details. For now, we're fine as we are. Let's work on wires. So here we have the sweep from walls, and we will create object merge as before. And I will copy my walls null here. I will set it to export relative path. And then we will use curve node to identify the first portion of it. For example, this portion. Then I will add another curve to extract the lines itself. So I will set first U and second U to 0 and 1 respectively. And I will set to extract, and I will increase the divisions. Then I need some kind of attribute noise. Let's use mountain to get this on position right away. At this point, I want to resample it, and I will have subdivision curves here. Increase element size, increase amplitude, go to the fractal and decrease roughness just to get initial variant shape for this. We can vary it more, make the element size on Y less to get more variation on this axis, or we can use Vex expression here. Next, we will use ray node, and that's the reason why we have done this in separate steps, because here I have my surface and here I have my curves, and I will use ray and set it to minimum distance. That way that will snap to the geometry. I can use smooth, for example, and I will increase strength and decrease quality, and I will disable group boundary just in case. Next, I will create a scatter node, and I will enable density, something like this. And then I will output attributes. It would be prim_num attribute. It would be the source primitive on which this point was copied, and source prim_uv, which will give me the value from 0 to 1 on each axis. It's vector, but actually it has only u. So source prim_uv, this is the value from 0 to 1 that represents parametric position on the current curve. Then I will sort this scatter node using the attribute, and this attribute would be source prim_uv. Next, for each of these lines here, I will create for each primitive. So now we have each line. Then I will duplicate it and fetch input, and I will place this sort to this fetch input node. And then I will delete everything that doesn't have the same attribute as number of primitive here. So we have source prim attribute right now, and I will use blast. I will add spare input. I will add create meta import node. I will send this meta import node to the spare input of blast node. So first of all, I need attribute. It would be source prim, and it would be equal detail -1 iteration and 0 as usual. Notice this thing is in backticks, which means it would be evaluated inside of this backticks. It will return just string. And if we press the middle mouse button, we will see the result of this particular evaluation. And we would need to delete non-selected. We need to set the group explicitly, so it would be points, group type points. And here we've created a point group for each iteration. Next, I will create for each number, which means that I want to perform something with this geometry certain amount of times. Let's calculate this amount of times. I will create spare input here. Probably it would be the better idea to have another fetch input, and I will send it here. And this iteration's value would be the amount of points in this spare input. Probably I can do -1. Not sure if it would help me. Right now we just duplicated these primitives. Next, in this inner loop, we will leave only 2 points. From these points, we will create meta import node for internal iterations. And here we will add additional blast node. We will feed this metadata node to spare input of internal blast. I mean the blast node. Add spare input, blast node. Here we will need to delete all spare inputs just to clean it out. And in group, I will set it to points, and it would be detail -1 iteration, 0 as usual. Then I will copy it. I will add space, and here I will use detail -1 iteration, number of iterations +1, which means we will keep only 2 points, like pair of points. Next, we will add carve node, and again, we will add spare input, feed the blast node to the carve node, and next, in first view, we will use point expression, -1 geometry, number of point would be 0, and we will use source prim UV attribute, which we generated in scatter, and we will use the X position of this vector. So as you can see right away, we have cutted this. And the second hue, instead of 0, would be 1. And that way we will have cut for each pair of points here. So that way, let me just show you in exploded view. So as you can see, we have rather random cutted points, but still we have all the details that we actually generated. I mean, the smoothness of curve stays intact. And let's try to compile all this thing just to get more performance, because as you can see, we have a lot of cuts. So let's do compile block, set it here. And for each input, which directly intersects this convex shape around loop, we should add separate compile begin. And now it's complaining. Let's try to use blast node instead of this one. Yeah, so in these nodes, like for each begin and for each end, we can reference something external, but we can reference something that already inside this loop. So in order for this thing to work, we need to send this externally, but still spare input is the way to go here. And let's do multithread when compiled, and let's check if our performance is good enough. Yeah, it's pretty good. Couple of thousand iterations and it still works pretty fine. So now we have random chunks. We can increase relax iterations to make it more, I would say, stable. Now when we have this, we can do something interesting. We will start with just adding attribute wrangle, and we will set position Y to curve U. We'll fit this to tramp as usual, and it would be remap Y, and we will multiply it by some kind of amount, and we will plus this. Right now we don't have anything happens because we need to generate our curve view attribute for each primitive that we have right now. So just curve view attribute, and probably we could disable the maximum segment length. So resample just calculates the curve view attribute. And now, as you can see, we have something going on. We will set it to -1, for example. We will correct this ramp shape. We will set it to B-spline, and we will make something like this to imitate hanging wires. There is some issues. First of which is the fact that each wire has exactly the same amount of hanging. So let's correct this one. We will create float. Let me just increase the size of the font. We will create float. It would be amount. I will copy it here. It would be equal amount. And instead of reference channel amount, here we will reference the variable. Then I will create another one just to keep things tidy. Rand amount, rand Y. It would be a random value using primitive number as a seed. We'll create some kind of seed here. We will remap this from channel min to channel max. And we will add this to amount, rand Y. So we kind of have base amount and we have additional random amount. So we can make this kind of like this. Here, for example, just to make it consistent, I will minus channel amount just to have this more convenient. We can do something like this. And let's adjust the minimum and maximum values. And the last thing that I can do before fit 01, I can remap this random Y using tramp, rand Y remap, and here we will use rand Y as a position for this ramp. And now we can control the probability of values from random. So we can decide, for example, that we need a lot less highly hanging one. So we can just remap the random value using this ramp. It can be pretty handy for us because changing the seed will give us the different result. So yeah, kind of like this. One thing I don't like though, if we have highly random scatter here, so I will disable relax iterations. I'm not necessarily happy with these smaller ones hanging as much as they do right now. So let's calculate the length of each segment and let's normalize it and let's use it as a multiplier here. So to do so, we will start with adding the measure node. We will set it to perimeter. Then we will use two attribute promotes. We will promote from primitive. We'll promote perimeter to detail, and it would be minimum. I will change new name and I won't delete original in this case. So I will leave this perimeter attribute and let's call it P minimum. Let's duplicate it and let's call new one P maximum. We'll set it to maximum. So in this attribute wrangle, we will get first of all minimum value. So it would be detail 0 P min, but max would be detail 0 P max. Here we will call P would be equal primitive from 0 input. Attribute that we need is perimeter, and the number of primitive from which we will get this attribute would be primnum. And then we will normalize this value. We will use fit function. The source value would be P itself. Minimum value of input would be min, max, the maximum value of input, and the output would be 0 and 1. Next, we will fit this to tramp. perimeter remap, and the value would be p. And then I will multiply this amount to my p value. Right now it would be equal 0. And if I set it to 0 in minimum, you will see that in some occasions it will almost completely stay the same as before. So as you can see, we modify pretty much only the longest ones. So I'm pretty happy with this one. And the issue I want to fix is the fact that we've lost some segments from ends. So to fix issue with missing segments, I've created a curve node. I've extracted the points from each of my curves. It's from 0 to 1, which is fine. But before that, I need to store the primitive index, and I need to call it somewhat the same as a scatter node attribute that we generated here. So primnum attribute in enumerate would be source prim. I will attribute promoted, and it would be so awesome if it worked right away. But unfortunately, we have to do additional things. So as you can see, here we have our source primitive, but after carve, we have lost it. So to fix this, I can use ray node. I will set it to minimum distance. And as a second input, I will use my curves with source prim attribute. And I will disable transform points. And I will import attributes from hits. And point attribute would be only source prim. So now we have our source prim intact right here. Next, we will need to get primitive UVW attribute from ray node, and we call it the same name as we have in scatter node. So it would be source prim UV. So that way we have like completely identical set of attributes. So we have source prim, we have source prim, we have source prim UV as a vector here, and the same, we have it as a vector here. But as you can see, we have 0 and 1. So ray node did its job correctly. And now, as you can see, we no longer have the issue with missing segments, and we have full control over the length of our curves. Next, let's handle the p-scale attribute, and let's do it like this. So here we have our primitives, it's 7, and let's generate enumerate. We will use additional node just to keep it separate, but of course we could have used just a source prim, but I got used to ID. We will promote it, attribute promote, from primitive to point it would be ID, and I will add attribute randomize. Right now we have CD, and we will use 2 underscores ID as a seed attribute here. But instead of using color, we will use p-scale, and the mode would be custom ramp, and we will fit value from some values. Let's test if it has been carried over our graph. So I will use round tube, and let's check. Yep, it looks like it's working. To have this more consistent, I can add polypath node, connect endpoints, and slightly smooth it before. Or I can copy and transform my curves, and I will get another layer of detalization here, still random for each primitive, but at the same time it's sharing the identical p-scale attribute. And let's add some randomization after that. So we will use pretty much the same technique as before. I can just copy this whole setup. I will enumerate this. I will attribute promote this. I will attribute randomize this. Now I have this thing completely random for each primitive, which is not what I want. I just need to add value to existing value to trying to keep overall character of the things. Adjust perimeter, influence. Next, I will calculate the orientation, and let's probably adjust the scatter a bit add relax iterations to get kind of more consistent look from it. And let's generate orient on these curves before we scatter points. So after the smooth, I will create node orientation along curve. I will set it to quaternion. And before my sweep, just to not have weird results, I will delete this orient attribute. Now I have my sweep working properly. I can use the orient from this scatter node. Let's call it null holders, for example. Let's copy this. Let's use object merge node to bring it here, and we will use merge node and merge this with this. And one nice thing though, for each primitive we have pscale attribute saved, so we can reuse it on our points. We will add copy to points, and for now let's add just a tube. Let's set it to z-axis. Let's add end caps here. Let's make it a lot smaller, and same with the height. But now, as you can see, we have kind of holders for our wires. Probably I need to correct this shape a little. And next we have a lot of intersections, which I want to avoid. We can use detangle node, which will help us to get rid of some intersection using pscale attribute, but it requires some rest position. So we will add rest position. Previous position would be rest. Of course, we need to use the curves itself. As you can see, it's acting kind of weird, but it's kind of trying to get rid of intersections based on pscale attribute. So we can increase the max weight. After that, we will use additional smooth, kind of like this. We can try to set it to sweep. And we have lost the consistency around our holders, and we can pretty easily fix this by using blend shape. We still have curve view attribute, and we can reuse this. So we will use attribute remap. Original name would be curve view, new name would be mask, and we will blend this detangled thing with curves without any intersection solving. So we will use blend masking as set from attribute. We will set it to from first input, and here we can control the way it will blend along each curve. And if you look at the wires right now, you will see that around our holders it's acting predictably. So let's set it to B-spline to have smoother interpolation. I think we can correct the sweep radius to something like this. Also, we can correct the tube radius. And now we have our nice wires. Let's create a null, call it wires, and let's add it to our final thing, probably here. We want to change the position of these wires, and also it's a good idea to optimize this using facet node and set it to remove inline points and slightly increase the distance to not have too much of polygons. And also, instead of these walls, we can use this curve, but actually we can just correct the positioning here. And the rest is just about tweaking things. Right now we have a plenty of these guys. Probably facet is too much. Something like this would be awesome. We can decrease the scatter. We can slightly adjust the detangle node and make it more prominent. Also, we can correct the walls using peak node and slightly adjust the distance. For example, something like this to get rid of any intersections. Decrease the amount of copies. And now we have our wires in place. And what's also nice that here we can add multiple carve nodes. Let's say adjust it to be here and just merge it With this one, we'll get something for each of these chunks, and we can easily add additional wires. Of course, there are a lot of things to be done, and we can add quote-unquote less touch to improve the look of wires. As you can see right now, we have the wires in x-axis pretty much as a straight line. So I would love to add some variation to it. I can do it in a simple way. For example, in attribute delete, you see that from this state, we sample pretty much area around our holders/straps, and we can leave it as it is. But before detangle, we can add additional mounting node, go to the vex expression, set offset to random from prim_num and some seed as usual. And let's multiply it by something really large, like 1000, but not too large to have a different noise pattern on each curve. We will set it to 0 centered, add is fine, and we will adjust the roughness of it, and we will increase the element size. So right now we have additional variation, and after we blend it back, we still have them intact. Holders is still stable. Let's look at the result. And there is some simplification of work for detangle. Of course, it can be adjusted like forever, something like this. Because this is almost like a rough sketch of what it can be, but it's already obvious that usage of parametric UVs is extremely powerful thing, and everything that we have currently, we have gotten from the simple combination of backbone and profile and the concept of parametric UVs. So this is pretty much the basics of creating this kind of structures. Of course, there is a lot of work to be done in bottom part, but because of the fact it pretty much requires the same principles and the same concept as before, I will do it quicker, and I will do it when we start adjusting for the shading. Thank you for watching. See you in the next shading and rendering parts of this course.